Type anything, feel free. Okay, I'm ready to go. I'm gonna start presenting about who we are momentarily and let David take from there. Sounds good? Type anything, feel free. Awesome. Okay, here we are. I'm gonna share screen. I'm asking everyone to mute just in case there's gonna be a lot of noise. Thank you so much. Okay, can you guys see my screen now? Everyone see my screen? Awesome. Okay, great. So welcome to our event. You should feel welcome to share your thoughts. And I want to introduce the school a little bit. My name is Vivian Zhang. I'm the school director of NYC Data Science Academy. We are the only national accredited data science bootcamp in US, especially accredited by ACCT. If you don't know what accreditation means, it usually means the premium quality of teaching and premium quality of job placement. It took us around 4 years to get our accreditation. It's quite a lengthy and difficult process. Okay, in today's event, you can feel free to ask questions, click on Q&A and submit your question. David and I are gonna monitor the Q&A constantly. At the same time, you can also share your thoughts by chat, by typing whatever you have in mind. Make sure you choose to everyone so the question is visible. Okay, awesome. So the school was established back in 2013, July. So this is our 9th year anniversary. Since we start to offer bootcamp in 2015, we has been constantly be rated as best bootcamp since then. We start to offer live session, I think around 2017, remote live, and we're also being consistently rated by Course Report and Switch Up as best online bootcamp. We offer data science bootcamp, which is a quick lane for people who want to transition into data science career. We also offer a lot of part-time professional development course. We are the only bootcamp teach Python and R at the same time with emphasis on Python. When our students graduate from our school, they walk away with hands-on experience and develop 4 projects at industry standard. And this school also offers lifetime job support. So a lot of students graduate long time ago, like 2015, 2016, they're getting our job placement support on their 3rd job, 4th job. Right now, we have over 1,000 bootcamp students who finished the career transition. We also have around 4,000 part-time students and corporate student work across the globe. And we're very proud we've been consistently rated as the best. Everyone work very hard. And if you never heard of bootcamp, usually it means it's a very intensive learning experience. Our signature flagship product is Data Science with Machine Learning bootcamps. Our next one actually starting soon. It's gonna start on August 15, and it's gonna last either 4 months or 6 months. It's very friendly for people who are working, so you can complete this program while you're working. And in September, we have 3 different modes. We have in-person, online learning in different lengths. Okay, I see a question. Yes, what's your question? Feel free. Would you like to type or ask? Okay, I'll continue. Around 2020, we launched a new program called Data Analytics Bootcamp. It's a lighter version of our data science machine learning bootcamp. So if you've never done any data science before, you're not sure you're gonna devote your next 10 years, 20 years on data science, this is a lighter appetizer size bootcamp you can try, but it teaches you to the level you can secure data analyst level type of job. Comparing to bootcamp, the main difference is your career goal become a data analyst or data scientist? and the content different is machine learning and big data. So you can research on different job type to decide which bootcamp will suit you better. And if you finish the easier version, the data analytic bootcamp, you can continue your training to data science bootcamp. So we have seen a few students finish analytic program and continue with machine learning, which is really awesome. Okay, so a little bit more explanation about what does online asynchronous learning and the synchronized learning mean. So most of our students are learning with us through the asynchronous learning program, which means you have all the basic content recorded. You have a lot of one-on-one meeting with your mentor, with your program manager, with your teaching support. People choose this because they don't want to commit it to sit in the classroom from 9 to 6, which gives them a lot of flexibility. But we also have in-person live online. It depends on the number of enrollment. Okay. So the application process is pretty straightforward. You submit an application, it probably take you 10 minutes to fill in an application. You're gonna do around 15 minutes to half hour behavioral interview. Then based on your level, we send different tech assessment. And the tech assessment takes about 2 hours to 8 hours. If you have some experience, the 2-hour version, you might be able to finish under 1 hour. Okay, so if you're interested, we are encouraging you to apply early to reserve your spot, because we have something called pre-work program. It's typically around 40 hours. It's good for brush up your knowledge in math. But if you already have like math degree or have done a lot of analytic, you probably don't need pre-work. It's just highly recommended. Okay, so we have a lot of alumni. Actually, if you go to our website, you can find our alumni directory. You can see around 700 to 800 student lists there. We only put alumni who give us video and photo release, so we don't have a full overview of everyone we ever trained. But it's a good sample size. You see where they come from, what kind of background they have, and where they land a job at. So that's basically my intro to our school and our program. If you have any question, feel free to message me here or write to admission@nycdsA.com. I'm gonna give the floor to David. I think everyone is excited to learn data science today.
Thank you. Yeah, so let me get my slides up. So just a little bit of background, I guess, on myself. I'm the data science coordinator here at the school. I facilitate any of the needs that you would have with your time here, just ensuring that all of your questions are answered, and do any of the project work and project building for it. But we have a lot of content to get in today, so I'm not going to spend a lot of time, if any, talking about myself. That doesn't matter. We're here to really understand how to get started in data science, right? And so this is going to be for individuals who are either transitioning into a completely new field, or someone who is looking to expand their skill set and really strengthen and have a firm understanding of data as it works in their company. And really, it doesn't matter what role you're in, whether you're in HR, you're in finance, you're in marketing, you're going to have an understanding to some degree of data analytics. Not data science so much, but at least the data analytics side, and understanding the data that your company has and what purpose it's trying to use it to serve, right? Whatever your clients' needs are, your customers' needs, and things of that nature, right? And so we're going to start with the fundamentals, the foundations of it, talk about some of the different roles, but this is really an overview of all of the different areas that you might find that are served in industry as far as data in general and different places of that, right? And so one of the things that I want to start with is just a couple resources in terms of places to go and look and start to really get an understanding of what's happening in the field. And the way that I think about it is that if you truly have an intent to learn something, everything that you do should be tangential to that, right? Whether you're reading a book, you're going to look at a blog, because every day when you go out into the world, millions of things are bidding for your attention, right? You got billboards that you see. We live here in the city. There's advertising everywhere. It doesn't matter where you go. There's screens. You have your phone, right? You have your friends and family that are telling you what you should learn and what you should do. And it really becomes hard to really hone in on the skills that you need in a particular field if you're just listening to all of the other noise that's coming in all of the time throughout our day, right? So what I say is the best way to gain a skill very fast is to just isolate yourself and focus on that and nothing else, right? So one of the places that I go in terms of just staying up to date on modern things that are happening in the field is just towards data science. So this is just a blog form where people post articles of different things, whether it's how to solve a problem or modern techniques, things that are surrounding data science in general. It's owned by medium.com, and that'll be one of the articles that we kind of look at, or there's a framework that we're going to get to in a moment that is a good thing to look at, and just keep yourself in the habit of continually focusing on the field that you're trying to learn and gain some kind of insights and information in that, right? And so there was an article again posted on there, and forgive me for a moment because the background, they decided to make it this bright green, but it comes from this article called the AI Hierarchy of Needs, and it talks about the different roles that data people in industry can serve and the functions that they have. A little hard to look at there, but we'll look at it in an easier format, which is just this pyramid, because this is the essence of what this article was trying to get at, right? And so it used to be that as a data scientist or anyone who was in this field, you had to really do end-to-end process, right? You had to do everything from the hypothesis testing, extracting the data, getting all of the information in, all the way to the end of building the models and developing them out, giving that information to whoever your stakeholders were. But some of these roles have been diversified. And at the bottom of the pyramid here, right, we have the data infrastructure engineer, the DevOps. And although most people think that the fancy, fun go-to thing is the AI machine learning engineer, just like your house won't stand without a base, the same goes for this data science pyramid too, right? Without good structures set in place and good data ingestion and structured format for that, the rest of this wouldn't work. And in data science, this is called garbage in, garbage out, meaning that if the data you're collecting isn't actually going to serve the purpose that your business has, it's not useful, right? It doesn't matter how well of an analysis you do. If you're doing it on information that doesn't pertain to what it should be, it doesn't matter, right? You just wasted all of your time because you weren't paying attention to the metrics or the data or information that you were supposed to have, right? So this base here, the data infrastructure engineer, this is someone who is really just going out and getting the information and trying to find a location to store it, whether that's on a disk or a remote server somewhere. And they're generally dealing with very messy, disorganized information. And they're less worried about the modeling side, and their main focus is just getting the information and figuring out how to store it. And data these days comes in all kinds of formats, right? It can be human generated or it can be machine generated. This could be things from web applications where we have consumer information that's coming in that we're going through and we're purchasing items and we're clicking on the screen somewhere, we're looking at ads, and all of this information is being intaked to serve a particular purpose, right? Usually in that case, it's optimizing sales funnels, looking at the positioning of the elements on the page and trying to figure out the best way to do so. Or it can come through things like I said with the display ads in terms of CTR, which is click-through rate. When is somebody looking at a page? What is being displayed at them at the moment? And now you can even find that this is sometimes distracting, or it's slowing down the website or things of that nature, because when you go to a website and all of those ads are being placed on it, they're actually in a bidding war, right? There's a number of vendors that want their data to be displayed, and so they're all giving a bid for the placement of where they want it to be, and it can take time for that page to render. But there's also other information, like I said, from machines as well. This could be things like sensors, and this is noted as the IoT or Internet of Things, in which case that there are sensors almost on every device, whether it's your fridge, your smartwatch, your car, even some toothbrushes, and all of these are just collecting information continuously and reading it in. And so Statista.com, they do a good job at aggregating information, and they said that currently there are roughly 36 billion sensors out there, and in the next 3 years that's expected to double. So that's just going to be a wealth of information coming in from all kinds of sensors all over the place. And we've seen with COVID in these last years and having sensor shortages and all this stuff. But this is going to, once that problem gets resolved and the supply chains start to function again, we're going to see them spread to everything, just in terms of collecting information. So when it comes to the part of like smartwatches and fridges, your toothbrush, this is stuff really to predict health outcomes, right? What type of food am I eating? How often am I eating it? How often am I doing certain things that are managing my own health? But in terms of production data, this can be things like soil and water monitors, right? I'm a farmer who wants to optimize my crop yield. And so I put sensors in the soil and to see, what's the temperature on any given day, what's the amount of water that these plants got, and how much yield came from the plants, and made sure that they were of good quality and all of those things. No, Rafi, in terms of prerequisites, I don't think you're going to need anything here. I'll describe all of that, and I have a lot of resources that I can just send at the end that I think will be helpful, the things that I'll talk about, but I'll send the links to you, and you'll have this recording as well to come back to in case I'm talking too fast or there's anything that you might miss, right? And so, like I said, a couple things, articles in terms of the adoption rate of IoT and AI sensors. And this market is, billions of dollars now and expected to grow 15.9% from the years year over year from 22 to 2028, right? So we have a large market in terms of the amount of information that's being collected and generated. And although it might be less interesting to some people to be infrastructure engineer or data engineer, it's still a highly paying field and very important, because like I said, if you don't do that process right, the rest of the process kind of falls apart. Above that, we have the data engineer, right? And they're really the part of transitioning that data from the raw information that's being collected in and storing it in useful ways. And typically this is going to be in two forms, structured or unstructured, and they perform a process called ETL, and we can see that here. And what that means is extract, transform, or load, excuse me. And so to extract it is just, like I said, pulling from the sensors, APIs, which is any website that you go to, like Best Buy is going to have an API that stores all of the data that you might see on the website, right? What type of television is it? And you're going to have things that are what I said, structured, meaning that they have a labeled information, right? If you're looking at a customer database, this is going to have key value pairs. And what that means is I might have a column that's called name, and then I have their first name, I have their last name, I have their social security, phone number, etc. But sometimes data is not so easily formatted, and it can be unstructured. And so the couple of nuances between that, right? Let me pull it up here. In the two forms that it might take in terms of what the data engineer is working with is the structured and unstructured data. And so on the structured side, we have things that are easy to search. They can be stored in data warehouses. So this is places where you would use languages like SQL in order to query the information from your company's database and start to perform some kind of analysis on it. Unstructured data, on the other hand, is stored in data lakes. And this is things like text files, videos, images that are not as easily labeled as things like we see on the other side with customer names, addresses. Those things are easily categorized and put into columns that we would be working with in a database somewhere. Above that, we finally get into what people see as the prettier part, or the more creative side of it, which is the data analyst and the data scientist, right? They can still be involved in cleaning the data, and not every process is perfect. Sometimes even down the line, there was inaccurate information, it wasn't logged right, or just isn't in the proper format that the data scientist or analyst wanted to have it in. So sometimes you still have to clean it and work with the data that you have. Sometimes there's missing values, right? It wasn't properly logged. As a customer, someone who goes on a website, maybe I forget to put information in a field. I leave it blank, or I don't put it in the correct way. And so this is why all of these different roles need to have continual conversation with one another, and not just have it a one-way channel of, here, I've passed the ball to you, now it's up to you to do whatever you want with it. There needs to be a dialogue back and forth between all of the different roles, because, for instance, maybe the data scientist or analyst is looking at income, right? Which originally starts as a string. It can have a $sign, it can have commas in it, but that can be not the form that someone wants to perform an analysis with it later, right? Maybe I just want it as an integer, a numeric value, which means I would have to remove things like the $sign or the commas from it. So they need to have this communication and say, all right, what format are you putting it in so that I can do my further analysis? And you're going to be handling other things like anomaly detection. In this case, it just means outliers, right? And so it's up to the data scientist or analyst to look at the data set that they have and say, is this an accurate outlier, or was it just misrepresented information? For instance, if we're looking at movies, right, and we're looking at the gross that they had, how much money did they make while they sold their film, you might look at a certain subset and say, oh, well, the numbers are exorbitantly large, and think, wow, these movies profited a lot. But the case might be that maybe it's in a different currency. Maybe all of them are in US dollars, but then you have a couple that are in yen, which has a much bigger magnitude. And so are these true outliers, or was it improper ingestion of the data, and was it not logged correctly? So that's really on the data scientist and analysts to start looking at those things and pay attention, and not just think that it's perfect when there were supposed to be people that did it down the line. The data analyst is going to be someone who uses tools like Tableau, Power BI, and really just works towards creating dashboards and visualizing the information. Doesn't have as much of a technical understanding of languages like Python and R that a data scientist would. And those are some of the distinctions there. Maybe they have a good understanding of SQL and how to query information, but maybe less so on the coding side of it. The data scientist is going to be someone who's getting, again, closer to the machine learning engineer, and they're going to have to develop certain metrics for testing the models and building out these models, right? If I'm a marketer, there are a couple of things that I might want to be able to see, right? Maybe I want to do customer segmentation and find the differences between the customer groups that I serve. And there's a term called RFM, which stands for recency, frequency, monetary. And what that means is some customers you have spend often, but they don't spend a lot. And some customers are the opposite of that. They don't always buy, but when they do, they spend a lot of money. And so the campaigns that you have and that you're going to run with these different these customer segments are going to be different, right? They're not always going to be the same for all of the customers that you serve, and you really want to have a different an understanding of the different customer segments that you serve. Other things that they might be doing is A/B testing, right? when you go to a website, and then your friend goes to the website, you might be seeing slightly different versions of what this site is in general. And that's because they're doing A/B testing, and they're trying to say, if I change this icon, the color of it or the position of it, how much better, excuse me, does this help individuals at going through the sales funnel, right? Is it better to position in a way, and we have to think about these things cognitively and psychologically. We read, at least here in the US, from left to right and from top to bottom. But somewhere else in the world, they could read from right to left, and in other cases, right? So how am I positioning this information that is best serving that area that it might be in, right? And so those are some of the techniques that a data scientist might use. They might get into simple machine learning algorithms like logistic regression. We're trying to detect whether it's fraudulent activity or not, and some other models and regression of that sort. At the top of the pyramid here, we have AI and machine learning engineer. And so this is going to have a much steeper learning curve than any of the other roles, in some sense, because they're going to need to learn things like linear algebra, calculus, statistics, and they need to have a firm understanding of the different mathematical processes that go into serving those models, right? And they have the ability to tweak and change the models accordingly to their understanding of the underlying mathematics. And they're going to get into the things like deep learning, neural nets, things of that sort, right? And like I said, all these roles are going to have communication with one another. The data engineer is going to have to talk to the data scientist and say, is this information in the proper format that you want it to be in? Like I said earlier, is it representing customer income, but it's in a string instead of a numeric value that I can perform statistical tests with? And how am I, aiding them in getting their process done easier? Same with the data engineer to the machine learning engineer. If the base of the pyramid, like I said before, is way off, and all of the information that you're ingesting is not going to serve the proper purpose, then it doesn't matter how much of an analysis I do later on. It's still going to fall apart, right? And not listed on here, but a very critical part of this puzzle is domain experts and business analysts, right? People who have domain expertise, a firm intuitive understanding of what the business needs are and what they serve. And also people like your stakeholders and your customers. These are people that, it doesn't matter what role you're in, you want to have a continual dialogue with to make sure that you're serving it in the right way, and you're measuring what matters, right? If you're not measuring what matters, then you could steer way off course. And that happens when we get tunnel vision and we pay too much attention to what we think the problem is, but really the metric is over here, and that's what we needed to be measuring. But now we've kind of steered away from that. All right. So it depends on what role you're in, to the degree of which you're going to have an understanding of these different things. Like I said, if you're a machine learning engineer, you're going to have a much better understanding of the algebra, the calculus, the statistics. And so I have a few resources. Again, I'll send you them at the end. But sometimes we're just told things and that we should understand them without not really having a reason or justification for why. And I think it's very important to know, why is it that we're using these things? And so in terms of linear algebra, this goes into things like regularization, which I'll talk about in a moment later on. But that's basically trying to prevent the model from overfitting. And what's overfitting? We'll say I have a data set on houses, right? But I'm serving a particular community, or I'm in a certain area. Maybe I'm in a coastal community that really the materials that go into the type of housing are different than they would be somewhere that is, for instance, in the center of the country, right? Or in another country in general. So the characteristics or the things that people want in that area are specific to that area. But when I'm building the model, I may get overfit, meaning that I'm paying too close attention to the patterns that are represented in that area, and it's not going to generalize well, right? If I try to take my model and I move it to a different city, my predictions may be way off because the characteristics of the houses and the things that are served in that community are much different. So you want to have a good understanding of linear algebra and how it functions so that you can prevent certain things like this from happening. Also, it goes into correlation and covariance. Essentially, what's the relationship between two variables? Do they vary together, right? Do they go up at the same time and down at the same time, or are they have an inverse relationship where one goes up and the other one goes down? In terms of calculus, this is going to be things used for optimization, right? In most of these models, we're trying to minimize the loss function. And what that means is we're trying to reduce the error and increase our prediction accuracy. And so having a good understanding of calculus and derivatives can help you to understand where a function has met its bottom, essentially. And then statistics, right? What are the characteristics of the population that I'm serving, or what is the probability that a certain event will occur, right? And so this is why you have to have an understanding of these three different areas of math, because they each serve a certain function when it comes to doing data science. As far as programming, there's Python and there's R, right? Python is a general purpose language, and this can be used for all kinds of things in machine learning, such as image recognition, self-driving cars. R is going to be more heavily used in academia. And so if you've ever had a graduate level course that pertains to any kind of math, computer science, you may, or data science, you may experience R. But it's also very strong for statistics and used in areas like healthcare. And then other ones like Scala, which is used for big data. And you can look up Apache Spark, which is used in the sense of trying to get big data organized and structured. And the last one, which may seem kind of not, maybe disparate from the rest of these ones, is experience written in visual communication. As a data scientist, and why it can be a little bit harder to get into the field in the role rather than a software engineer. I'm not just doing coding challenges and trying to solve all of these puzzles, but I need to be able to tell it and articulate it in an effective way. I need to be a good storyteller, and this involves knowing the audience that I'm speaking to, right? Whether it's shareholders, customers, clients, other members of the data science team, right? Some people are more technically minded than others, and you need to be aware of that, because it may be the same information, but depending upon the audience that you're giving to, the story is different, right? In the sense that if I was talking to my data science team, maybe I can talk about the models and methods that I'm using, but if I'm going to present a deliverable to an executive, I'm going to tone it down a little bit. So I'm going to use different language and the way that I communicate that. So you need to have good communication skills. And the other part of that, right, if I'm giving it to other members of my team, let's say I have a really good understanding of how to build a model, how to do the mathematics behind it, but I don't know how to communicate that to anyone else on my team, they're not going to be able to use all of the information that I had at my disposal, because I don't know how to translate it into something that's effective for them. All right, and kind of going along the same points, right? There are different ways to practice this, right? There are a number of courses you can take and math that are online or in person, and it's good that you continue to do that and have some base understanding of the way that these things function, right? When it comes to coding, it's important to not just continually watch exercises or watch the lectures, should I say. It's very critical to practice exercises and building projects and things of that sort, because you get into what is called tutorial purgatory, essentially, right? I'm watching lectures over and over and over again without actually getting the hands-on skills that I need. And when you're building a project and you're going through the work, you really see how it starts and how it ends, and have a thorough understanding of all the how the different parts that you've been learning connect. But if you're just learning them disjointedly, then it doesn't help you really gain the skill set of being a data scientist or anything of that. You're just watching it, and you know, it's in one ear and out the other, and it doesn't really help you reinforce it. It's like riding a bike. You need to do it over and over again to master it, right? You're not going to pop a wheelie the first time you get on a bike. It's going to have a good understanding of learning how to ride the bike first, and then finally being able to do tricks of this sort, right? So in order to be able to do that, you have to practice, and that happens through exercises and happens through building projects. And again, like I said in the last slide, communication is a very critical thing. Also, being able to have explainable models, and this is something that is becoming more apparent these days, is that if you're talking to individuals, they want to know how your model's working and how you can change it, what purpose it serves. Netflix hosted a competition on Kaggle. They were trying to get a better recommendation system, and the first place people ended up having an extremely accurate model, and it was good at giving recommendations and all of the sort, but it was overly complicated and they couldn't explain it. And so the Netflix, they just kind of didn't went with it. They went with one of the other ones, or just disregarded it in general, because it was just too much and didn't have the utility that they thought it should serve, although it was very accurate. So you need to be able to communicate what's going on. If no one understands your work, then no one cares, right? If I just started speaking a bunch of gibberish, I'm sure everyone would just leave the room because they don't know what I'm trying to say, or the needs and purposes that I'm trying to serve, right? So it's very important that you learn how to communicate and do it effectively. Like I said, if you're going to get a deliverable and you're going to give it to your boss, and you go up to them and you thought you've been working so hard the entire time, or more often this happens when you're dealing with clients, right? Sometimes you have one conversation with the client and you go, okay, I know what your needs are, and you just start putting your head down. You're doing an analysis, you're working hard, you're doing it day in and day out, and you go to give it to them and they say, it's not at all what I wanted. It's because you closed that communication channel, or you didn't continually keep it open, right? And that's extremely necessary. Like I said, if you're talking to the client, you need to know what their needs are, and continually update yourself and say, is this in line with what you're trying to do or what you want to achieve? Same goes with, your boss, executive. You're reaching out to them. Am I actually going towards what it is that you're looking for, right? And so you need to ensure that the metric is the right one, right? And that you're not all of a sudden analyzing something else that you shouldn't have been in that meantime. So some of the other things, right? I had a number of resources that go through, and I'll send these to you at the end. Like I said, you got to have a firm understanding of math and linear algebra if you're going to be a data scientist, and get an understanding of that. This one here, right? Not everyone learns the same way. I myself am a very visual learner. The things that I gain information from is seeing it done with graphs and information. When I was younger, and the teacher just wanted to give me a formula, it didn't completely stick in my head. And so there are different ways that we learn. And I think that these are good courses to come through just to gain a base understanding of some of the mathematics that are being utilized in the field and necessary to have an understanding of. Again, just knowing the usefulness of linear algebra and calculus and some of the ways that it plays in these things, that it's not just chosen by random. They have a use case, and there are reasons why we need these underlying structures and mathematics in these parts. I want to take a second to pause because, I've kind of been barreling through this And just want to give you time to ask any questions if you have any. Take a second to breathe. And again, I know it's a lot, so feel free to continually throw them out there, or put them in this chat, or ask them aloud, or stop me at any moment if you'd like to ask any questions about the things that I'm talking of. All right. So what kind of tools do you need, right? It depends on what language you're using. Are you using R? Are you using Python? Our studio just changed and rebranded itself. It's going to be called Posit soon. So the things that we have here are going to need to be updated. But if you're trying to just code out solutions, you want to have something that is called a IDE, or integrated development environment, right? This is somewhere that you're doing your code. Typically, code was, before it was done in a terminal or command line interface, where you had this little black box and you were doing everything you needed there. But nowadays, we want it to look prettier, right? And so our studio is a application that is useful for graphing and visualizing information in R. And they have application-based things for Shiny. And what that is a web-based application that I can show something that I've built. Oh, let's refresh this. Give it a second here. And so online, hosted for free. This is just a student project that went through, and this just gives an overview of a sample of a project that you could build when you're trying to display information in R and R Studio and Shiny, right? You want to have a clear objective to your project, right? She enters with a nice introduction. We're trying to look at national emergency, what's happening. There's tornadoes, there's all kinds of wildfires, there's things going on. So start your story, going back to the communication piece, with something that compels people to move, right? Like I said, if nobody cares about what you're talking about, it's not gonna gain traction. All the time, people are developing products, kind of get tunnel vision. They think about, oh, other people are gonna need this, but when it comes to market, it doesn't really serve the way that it is. So this first page here gives us an understanding of the emergencies, the things that are happening out there, and then some graphs and visualizations in terms of disasters that are happening. We have emergency counts, highlighting here some of these critical points and major things that are happening in 1996, 2011, 2020, right? These are things you want to think about as a data scientist. As soon as I look at this graph, I'm seeing the high points. My eyes are being drawn in, and this is using visual perception as an aid in terms of telling my story, right? You're not just trying to look at all of the graph and understand what's happening. It draws your eye in and kind of speaks to the critical points and problems that are happening. And now that we can see these overall trends or things that happen, we can start to do a further investigation into it and say what was going on in these years that may have had these counts increase drastically. So utilizing things like dashboards, applications can help aggregate information and condense a lot of information into a nice spot and tell a compelling story. Also, we use things like notebooks, and this gives a combination of what's called markdown, or just regular text that you would see with embedded links and labels and nice emojis these days, and but also code cells, right? If I want to run this, I could, and it'll give me this nice output for the plot, right? So whereas the older case was using things that were just in the terminal, now I can actually run lines at a time and see if what's generated and how I can tweak it, and also I can put it in this nice format so that when I go to give a deliverable to my boss executive, I can tell part of the story and not just have the code in there, but I can kind of tuck away those cells, and I could say, here's what's going on behind the scenes, give you a little bit of background and tell you the story. And here's the code that went into involving it and creating these graphs. And it's a nice way of displaying all of this information in a way that's useful more than just having a code cell running, right, trying to perform some kind of process. All right. And so what are some of the machine learning things that you need to know, right? And I'll type these ones out because they're very useful in terms of doing data science work, right? We have pandas, and this is called pandas because it means panel data. But what you should look at as a data scientist or analyst who's trying to gain the skill set is their API reference, right? And what this is a guide to how to use the package, all of the code and functions, right? They've organized it in a nice format so that when I'm looking at it and I'm trying to do data manipulation, I know all of the functions that I can do. I have a brief description of what they do, right? If I click on that, again, I have even more detail. What kinds of things, parameters does this take? What does it do? What kind of output does it have, right? And so pandas is one that you're going to use typically for data manipulation in Python. If you're going to be doing machine learning, you're going to want to know scikit-learn, which has a lot of the models that I've been talking about built into it. And again, this is all just good documentation that is useful for machine learning and process and doing these models. If you want to do more of the further end, going towards the machine learning engineer, and you want to do some deep learning, you're going to be using tools like packages like TensorFlow and Keras. And these are things that are getting more, like I said, to the deep learning, building out neural nets and things of that nature. If you're someone who's more on the R side, right, rather than the Python side, or you have a combination of both, tidyverse is going to be comparable to what I just showed for pandas, right? If you're doing manipulation of data frames, most people know what tabular data is. If I've looked at Excel, I have a row is an observation, right? If it's customer transactions, each row is a customer. Each column is a feature in that it describes some kind of characteristic about the customer there, right? And this last one here, hopefully comes up. The carrot package is going to be comparable. Let me get this one maybe a little bit more visually pleasing. This one's going to be comparable to the scikit-learn that I just described in Python, where it has a lot for the feature engineering, the creating of models and model tuning and everything of that. So again, if you're going to be on the Python side, you're going to be looking at things like pandas, scikit-learn, TensorFlow. If you're on the R side, you're going to be looking at things like tidyverse and Caret. All right. So what is the workflow? A lot of people think that they're just going to be handed a data set and all of a sudden they're going to be able to explore it and do whatever they want. It's not actually the case, or not always the case that happens, right? A better approach in the way that you're going to look to serve a business's need, or a business is going to be created to serve a certain need, is it's going to start with a problem statement, right? What's the task at hand? What problem am I trying to solve? Question here, right? Which factors contribute most to ad clicks? What's the ultimate goal of the project? And how can I develop metrics around that are going to go towards serving it? And similarly to the data science pyramid that I started with, if you're not asking the right question, the whole process afterwards doesn't yield anything interesting. People are going to be expending a lot of effort, but you're just asking the wrong question, right? Is your mission misaligned with what you're trying to solve? And it doesn't matter how much work you do, it's not going to go towards serving that problem. In terms of the data analysis, once we have a clear problem statement, once we know what we're trying to solve, we go into collecting information and data that can test that. Right? Am I trying to look at employee satisfaction and figure out what's causing them to leave my business? If so, then I need to monitor things around that, right? giving out surveys, right? What is our employee satisfaction? When are the low periods? What's going wrong? Are they disgruntled with the area that they're working with, the bosses, or whatever else? Start to look at the problem and figure out things that are surrounding that, and not just asking how many fridges are located in our office space, which has nothing to do with the employee satisfaction. Maybe it does if they're hungry and they need things like that, but you need to have metrics that are aligned with the problem that you started with. And then once you have the information and the data that you need, you can get into the model deployment, right? This is where you start to explore the data that you're working with, really understanding the problem, which goes into what kind of problem is this? Is it classification? And I'm trying to identify what type of object this is, or is it regression, right? Am I trying to predict the sales price of a home, et cetera, right? And then we need to continually update the models. We need to do the A/B testing and see if the things, like I said, are aligned properly. And this happens all the time. For instance, when you go to Google, there's a ranking system that'll put the ads at the top versus the bottom. And generally, it's not the one that spends the most that gets the first line, right? If that was the case, then the people with the most money would win. And that wouldn't really have an optimal outcome. Usually what it's measured by is things like click-through rate, right? How much are people actually interested in this link versus how much money is being spent? And all of those things are adjusted accordingly, right? If my first link is not getting clicked as much as my second link, maybe I'm giving a better position to someone who doesn't actually deserve it. And I want to retrain my model and optimize it and change it to really adjust that. All right. So what are we trying to do? Like I said, there are different types of problems that we're trying to solve. The first one here, and the two main ones that you'll really see as a data scientist, are regression and classification. In regression, we have a continuous outcome, or whatever our Y is, right? This would be things like predicting the sales price of a home. Some of the features, the X variables that you would see would be maybe the condition of the home, the year it was built, has it been remodeled or not? Does it have a pool? How big's the square footage, etc. Right? And we're trying to predict the sales price given all of those other things. Models that go into this are things like linear regression, ridge and lasso, which are penalized models based on how much information we have, and things of that sort, right? Classification goes into identifying a discrete outcome, meaning I'm trying to see if is it fraud or not? Are they going to return the good or not? Is there going to be a defect in my product or not? Things of that nature. In that case, it's a binomial outcome. Again, fraud detection. It was either fraud or it wasn't fraudulent activity. And the features that would go into that, right, if I'm looking at customer transactions, would be their purchase history. When was their last purchase? How much did they spend? Right. And so you get those alerts on your phone and say, oh, well, someone in another country was trying to buy a good. Well, you've never been there. You never bought that good before. So clearly it's an indicator that someone is doing some fraudulent activity. Some things are less obvious than that, but that's one case of it. In terms of what is called multinomial classification, this is trying to see multiple outcomes, right? This would be image classification, in which case I would be looking at pixels of an image, right? I have a photo of some kind of animal per se, and I want to know whether it's a cat, a dog, or a horse, or a giraffe, whatever it is, right? I have more than one category that this could fall into, and I'm trying to figure out whether it is or not, right? And this would be models like logistic regression, decision trees, or in the case of the image recognition, things like neural nets, more complicated models. Lastly, on here, we have forecasting, and this is trying to see a trend in the next X range, meaning that I'm trying to not only predict what the current value of it is, but forecast into the future what it might be, right? And so things like crime rates in the next coming years, or as we've seen recently, COVID infection rates. Can I use the current values of what it is to predict future values, right? And so we'll hear of things like trend. Is it constantly going up or down? or is there seasonality, right? Ice cream sales go up in the summer and down in the winter, obviously, but that's a pattern that happens repetitiously year over year. And so that would be seasonality. Models that are included for things like forecasting are usually time series. If you want to look them up, they're called ARIMA or SARIMA. Essentially, they're accounting for things, like I said, seasonality and trend, and looking at the past values of it. Common techniques that we'll find in data science, I mentioned a little bit earlier, regularization. We're trying to prevent overfitting, right? Generally, when we're building models, we split it into train and test sets. We want to fit our model to the training set, but we don't, like I said before, if we're looking at housing in a certain area, we don't want to overfit it to that area because we want it to generalize to new unseen data. We want to be able to transfer that model elsewhere and predict based on maybe some changing of characteristics, right? If our model obtains 100% accuracy on the training set, it's probably a bad indicator saying, maybe it's going to perform poorly on unseen data because we're paying too much attention to the nuances of the data that we already have. In terms of parameter tuning, this is, think of a sound system. You have your bass, you have your treble, and you're really trying to focusing on getting clear audio. And that's the case of parameter tuning, is we want to optimize our models to get better accuracy and score, and try to do better in those things. As far as dimensionality reduction, what you really need to know about that is, for instance, in your data set, you might have hundreds or thousands of features. Like I said, if I'm looking at, there's a good data set that's called Answer, and it looks at all kinds of body measurements of individuals, finger length, leg length, and etc. And it has 90 something columns, meaning that there's that many individual measurements of the individuals. But it can be reduced using things called principal component analysis, TSNE. And what that means is taking high dimensional data, projecting onto a lower dimensional space, and all that fancy language. What it means is, for instance, if you perform TSNE on the Answer data set, and you take all of those 90 measurements and you reduce it down to just your X and your Y, what it finds is that the most explainable things of body characteristics is height and weight, right? And so out of all of those 94 things, the model can interpret that being able to accurately represent this information, the most important characteristics is how tall someone is, or how heavy or skinny they are, right? So being able to take that and reduce it down to something that's more explainable from all of the different features is very helpful. But the most important one here is feature engineering, right? And this could be the most difficult. It provides richer data for the algorithm. And what this means is not just using the features that you're given in a particular data set, because things like parameter tuning can use a lot of computational resources. It can take a long time to fine tune those dials, but sometimes the people who succeed in performing in better models are ones that have come up with interesting features. Simply, this is like trying to extract more information from the existing columns. And an example of which, a very simple one, is creating a new feature that's basically, if I'm looking at homes, timesing the quality of the home by the square foot, right? I'm not just looking at one of them individually, but I'm looking at the interaction of these two features and how they might have a different relationship than they would otherwise. So you could save yourself some time and come up with some interesting features rather than doing some of these more complicated processes. And finally, just to wrap these up, right? Once you have a model ready for deployment, we can start to utilize cloud services, web services that help to complete that end-to-end process, right? How do we start with the hypothesis and really get into the model building and testing and changing of certain features, optimizing our code and models, and then finally delivering it out as a service, right? Putting it in to industry and utilizing it after all of the work that we've done. And so there's a number of services, right? Amazon Web Services, Azure by Microsoft, Google Cloud, And what these do is they host the, the large amount of information and allow us to build and test models and store all of that metadata that happens as we go through the process, right? Once we find a better model, we kind of log it, we save that, and then we continue to do that part of updating and testing it and seeing if it's performing better. And so some other smaller scale versions of that are Docker and Kubernetes. Which is, again, similar process, but generally for smaller businesses these days instead of the major cloud platforms that we see. And I know a lot of information, but we made it to the end. And if you do have any follow-up questions, I'll stay after and answer them. Other than that, thank you all for being here. And I'll just send a bunch of links now in the text, and you can store them however you wish and save those. So thank you.
This is awesome, David. Any other questions, guys? Feel free to ask questions. There is a question about, is there any prerequisite or things you should know before starting out? What's your opinion, David?
Yeah, I answered that a little bit earlier, but majority of the things, if you're getting into this, is really just starting to get an understanding of the math, the tools that surround it, some base understanding of these languages, and trying to look at the, like I said, the documentation, going through that and utilizing that effectively, because Google it doesn't care about your feelings. When you ask it a question, you need to be very concise and direct with it, or else it's not going to give you the result that you want, and you can just get flooded with all of the information that's out there. So it's good to look at the documentation that comes and encompass with these tools and packages that we're doing. Yeah. Go ahead.
You go ahead. I was trying.
You might have a better answer for this next one in terms of why our studio is rebranding.
I was speaking with our studio team this morning. They asked me for inputs. I really like the idea they're rebranding, because the tool is go beyond R now. They are including Python, Julia, and a bunch of tools. So the rebranding also reflects their market position. Instead of being just R IDE, they're entering the market similar to like our data robot, data IQ. So their valuation actually is 100 times more if they rebrand and enter a bigger market. So I think it's a really smart move. Any other questions?
Can people see those links that I'm sending, or is that just us that can see them? Can anyone see it?
Yes, I can see it.
Can the other people who are participating? No. Okay.
If you send, you need to send to everyone.
Yeah, in the drop down, that's not an option. I just have the NYC director, the host, and panelist.
I can send it. Can everyone see it? There is a towardsdatascience.com link.
Okay, I have a few more here.
Great, awesome. I have confirmation. You can see it now.
Okay.
Perfect. At the same time, if you guys are interested in our part-time class, I have a 20% coupon code to give. I'm gonna type it in the chat. The coupon code is PD 20% off. So it can be applied to our part-time class. I'm also gonna post a part-time class link. Okay, feel free to check out our class with the 20% coupon code.
All right.
Okay, the class will start they have different start time. The earliest one starts on August 7th and August 6th, which is our class and the Python class. If you're interested, you should register either today and tomorrow. We're gonna finish all the registration at least 2 days before the class. Okay, thank you. Hope to see you join our class soon and keep being updated by our event. We always have Tuesday event. Student is asking more information on the class price. So our part-time class usually around 20 hours to 35 hours. The price is between $1,590 to $3,900. So the more advanced, the more pricey. And I think most of the beginner class is between $1,590 to $1,990. And with 20% discount, it will be more affordable. Okay. I think the two most popular class is the intro Python class. I'm gonna put this in the chat. The second popular class is the data analytic and visualization, either Python and R. Both of them are very popular. Okay, so yeah, definitely check them out and hope you will have a chance to utilize the coupon code. Any last minute question? Great, awesome. It's so amazing to have all of you stay with us. We have more questions. JT said, how do the intro class increase salary? If you are working at a firm which is still using Excel or other job and the drag and drop tool, most likely after the intro class, you will have a good understanding how to use all the basic data analytic tool. And Angie asking, do we have a math refresher class? Yes, we do. If you're coming to the bootcamp, we have a pre-work class, which consider a math refresh class. Yep. Angie asking, it's been a while since undergrad. Sounds like I need that. Yeah, many people enjoy our pre-work. So even you don't need it, it's good to brush up a little bit so you can be sharp, right? Awesome, all great questions. So hopefully we will see you in the future Tuesday events. Also have you join us in the weekend class. Everyone have a good night. Great job, David.